today we are going to talk about how to draw the state diagram and trellis diagram of a convolutional code. So, today's lecture deals with state diagram and trellis diagram of a convolutional code. So, we will start off this lecture with description of how to construct the state diagram of a convolutional code, and then we will talk about the trellis diagram. So, before we talk about state diagram and trellis diagram, just few words about convolutional code and its equivalent state diagram. Since it is a sequential circuit, the convolutional encoder, we can represent it using a state diagram, and we are going to make use of this state diagram and trellis diagram when we will be decoding the convolutional code. So, state diagram is described as follows. A state of an encoder is basically defined by the contents of its shift register. So, if you have a rate 1 by n code whose memory order is m, then we define the state at time L by S sub L, where x L minus 1, x L minus 2 up to x L minus m, these are essentially the contents of the shift registers. So, the contents of the shift register will define what is the state of the convolutional encoder. So, if we have a convolutional code whose memory is m, a rate 1 by n code, then essentially we will have total 2 raised power m states, because we will have one set of shift register to represent this convolutional code, because k equal to 1, and since memory is m. So, total there are 2m different possibilities for the state, depending on whether the bit is 0 or 1, which is stored in the shift register. And then output of a convolutional code, as we know, is function of what is the input and what is the current state. And what happens when we receive a new bit? When we receive a new bit, the convolutional encoder is in a particular state, let us say at time t. When it receives a new bit, that new bit will transform it, will take it to some other state, and some output will be emitted. So, we undergo what we call a state transition whenever a new information bit arrives. So, what happens when the new information bit will arrive? It will transform it from a given state, let us call it S L, to another state S L plus 1, and this transition happens when you receive a new information message bit. And these state transitions are represented in a state diagram by a directed edge. So, if there is a directed edge from state S L to state S L plus 1, that means from state S L you will undergo state transition to state S L plus 1 when a particular new bit has arrived. And normally what we do is we label these state transitions with what is that information bit that caused that state transition and what are the coded bits corresponding to the state transition. So, let us say there is an information bit 0 which causes you to move from state 0 0 to state 0 1, then in this we will draw a directed graph, directed edge from state 0 0 to state 0 1, and we will label it by the input which is 0, and we will also write what is the corresponding output. So, that is how we will basically label all these state transitions, and in a state diagram we are essentially enumerating all possible state diagram corresponding to all possible states. So, let us take the same example that we have been dealing with so far. This is a rate 1 by 2 convolutional code with memory 2, and what are the state of this? So, state of this convolutional encoder is given by what is the content of these shift register, which I am denoting by these blue dots. So, what is the content here and what is the content here? That is essentially the state of the convolutional encoder. As you can see, basically when you get a new information bit, depending upon what the state is, you will get corresponding output. And what happens in this new information bit will cause in the next cycle, this information bit will move here, and whatever was here will move here. So, there will be a state transition, because this UL will move to this location, and what was stored here will move to this location. Okay. So, let us try to draw the state diagram for this convolution encoder. So, as we said, basically these are the states of the convolution encoder. So, we first enumerate all possible state and all possible input. So, since the memory is 2, the all possible states are 0, 0, 0, 1, let us say 0, 0, 0, 1, 1, 0 and 1, 1. And corresponding to each state, we can have input 0 or 1, input 0 or 1, input 0 or 1, input 0 or 1. Okay. So, now let us look at each case separately. So, we have an input 0 and initial state 0. Now, what is going to happen in the next state? So, when there is a transition, this 0 will move in here, and this is 0, 0. So, this 0 will move here. So, when a 0 comes, and if you are in initial state 0, 0, this will move to state 0, 0. So, it will remain in state 0, 0 if the input is 0. And what is the corresponding output? Since the input is 0 and the state is 0, what you will get here is 0 plus 0 is 0, and 0 plus 0 plus 0 is 0. So, output will be 0. Now, let us look at this. If the input is 1 and initial state is 0, 0, then this 1, the one which is here, will now move to this location, right. So, the next state would be 1, 0, because 1 from this input will move here and 0 from here will move. So, the next state would be 1, 0. And what will be the output? Since the input is 0, initial states are 0. So, 1 plus 0 will be 1, and 1 plus 0 plus 0 will be 1. So, this output will be 1, and this output is 0, 0. We have already mentioned this. Let us look at next case, initial state 0, 1. So, initially this is 0 and this is 1. If the input is 0, what is going to happen? This 0 will move here and this 0 will move here. So, when you get a 0 and the initial state is 0, 0, next state will be 0, 0, because this 0 which is here will move to here, and this 0 will move to here. So, next state will be 0, 0, and what is the output? This will be 1 and this will be 1. So, output is 1, 1. Next, if the initial state is 0, 1, but the input is 1. So, in that case, the next state would be this 0 will move here and this 1 will move here. So, next state would be 1, 0, and what is the corresponding output? This will be 1 plus 1, that is 0, and this will be 1 plus 0 plus 1, that is again 0. Okay. Now, let us look at another case. So, next you have initial state 1, 0. So, initial state 1, 0, if the input is 0, then the next state will be 0, 1, and what is the output? If the input is 0, the output will be 0 plus 0 is 0, and 0 plus 1 plus 0 is 1. So, output is 0 1, and if the input is 1, then the next state would be 1 1, and the output will be 1 plus 0 is 1, and 1 plus 1 plus 0 is 0. And finally, if the next state is 1 1, let us say if the input is 1, then the next state is 1 1, and the output will be 1 plus 1 is 0, and 1 plus 1 is 1, and if this is instead of 1, if this is 0, then next state would be 0 1, and output will be 0 plus 1, which is 1, and this is 0 plus 1 plus 1, this is 0. So, note that we have drawn all possible state transitions corresponding to all possible inputs and all possible initial state. Now, what the state diagram does it represents the state table graphically, and how do we show it graphically? So, we will go back to this. So, note here, so we have 4 states 0 0 0 0 1 1 0 1 1, and we are showing each transitions graphically. So, if you go back and see here, if the initial state is 0 and input is 0, it remains in 0 state and output is 0 0. So, how do we denote this? Initial state is 0 0, input is 0, corresponding output is 0 0, and it remains in all 0 states. So, that we are denoting like this. Now, what happens when you are in 0 0 state and you receive a 1? If you are in 0 0 state and you receive a 1, you move to next state 1 0, and the output is 1 1. So, when you get a 1, you move to next state, which is 1 0, and the output is 1 1. So, note how I am writing this state transition graphically. So, I show by a directed graph transition from state 0 0 to state 1 0, and I am labeling this state transition by the corresponding input and output. So, 1 is the input, and after slash I have the output. Similarly, you do it for all the states. So, if the initial state is 0 1, and you get a 0, you move to 0 0 state and output is 1 1. So, if you are in initial state 0 1, you receive a 0, you go back to all 0 state and output is 1 1. So, this is taken care of, this is taken care of. If you are in initial state 0 1, you receive a 1, you move to 1 0 state and output is 0 0. You are in 0 1, you receive a 1, you move to state 1 0, input is 1, output is 0 0. This is done. State 1 0, initial input is 0, you move to state 0 1 and output is 0 1. So, you are in state 1 0, you receive a 0, you move to state 0 1 and output is 0 1. So, that is this, okay. And so, this is taken care of. And what happens when you receive a 1 and you are in state 1 0, you move to next state 1 1 and output is 1 0. So, you receive a 1 from when you are in initial state 1 0, you move to state 1 1, which is this. This is the input and corresponding output is 1 0. And finally, when you are in state 1 1, if you receive a 0, you move to state 0 1 and output is 1 0. So, you are in state 1 1, you receive a 0, you move to state 0 1, input is 0, output is 1 0. And finally, state 1 1, input 1, you remain in state 1 1 and the output is 0 1. You receive a 1, you remain in state 1 1, input is 1, output is 0 1. So, note that here I have graphically represented all possible state transitions corresponding to the convolutional encoder that we have considered, and this is my state diagram. Okay. So, next let us talk about trellis diagram. So, in trellis diagram we include another dimension which is the time dimension, and how do we show that time dimension? So, let us first talk about what is a trellis section. So, in a trellis section we represent each state twice. How do we represent each state? Let us take this example. So, here we have 4 states, right. So, if I have to draw a trellis section corresponding to this encoder, how will I do it? What I am going to do is, I am going to write all these 4 states here, and I will write all those 4 states here. Next, what I am going to do? I am going to add a branch connecting a state at this time instance at time L to a state at time L plus 1, if there exists an input that will drive the encoder to state SL plus 1 from state SL. So, what we do is, we at time let us say L, these are the states corresponding to at time L, and these are the states corresponding to time L plus 1. So, there will be a valid transition from a state at time L to a state at time L plus 1 only if there exists an input that will drive from this state to some other state in the next time instance. For example, let us go back to this. If you are in state 0 and you get a 0, you remain in all 0 state. So, this can be represented here. Let us say this is my all 0 state, let us say 0 0 state, and this is also my 0 0 state. So, there is a transition from here to here, and what is that input that causes this transition? That input is 0, and what is the output corresponding to that? It is 0 0. So, I will label all those transitions which are happening from state at time SL, I mean a state at time L to any state at time SL plus 1, provided there is a valid transition. Okay. And a trellis diagram is obtained by joining trellis sections at different time instance. So, what I am going to do is, to draw the complete state diagram, I am going to join trellis section at time t. For various times I will join them together, and that is how my trellis section will be, trellis diagram will be drawn. The interesting thing is, in a trellis then we can see all possible code words. Any valid transitions basically is a valid code word. So, let us say initially our encoder is all 0 state and it goes back to all 0 state, then all possible paths from all 0 state to the final all 0 state will enumerate all possible code words that we have. So, let us take another example. This is an encoder. Now, following the same procedure as we explained earlier, we can draw the state diagram for this. So, where are the states? So, this is one state, this is another state, and similarly we can find out for all possible initial state and all possible inputs what are the next state and the corresponding output. So, this in this case turns out to be this. So, when you are all 0 state, if you get a 0, the output is 0 0 and you remain in all 0 state, but if you get a 1, your output is 1 1 and you move to state 0 1. So, this is the state diagram for the convolutional encoder I have just shown. Now, how do we draw the trellis diagram for this convolutional encoder? So, as we said, at each time instance, let us consider this time instance, this and this. So, this is one particular time instance. So, what we are going to do is, we are first going to enumerate all possible encoders and we write them twice. So, in this example we have 4 states 0 0, 0 1, 1 0, 1 1. So, what we do is we write these states twice 0 0, 0 1, 1 0, 1 1. Next, we draw a state transition from each state to the next state, provided there is a valid transition. So, what we are going to do is we are going to map all these state transitions into the diagram that we just showed. So, let us take this example. So, we are in 0 0 state and we get a 0. The output is 0 0 and we remain in state 0 0. This is shown by this transition. You get a 0, output is 0 0 and next state is 0 0. Now, next if you get a 1, you move to state 0 1, output is 1 1. You get a 1, you move to state 0 1 and output is 1 1. Let us say you are in state 0 1 and you receive a 0, then you move to state 1 1 and output is 0 1. So, how is that denoted? You are in state 0 1, you receive a 0, you move to state 1 1, the output is 0 1. Similarly, when you are in state 0 1 and you get a 1, you move to state 1 0 and the output is 1 0. So, this is denoted by, so you get a 1, you move to state 1 0 and output is 1 0. We repeat the same for other states. So, let us say you are in state 1 0. When you get a 0, the output is 0 0 and you move to state 0 1. When you are at 1 0, you get a 0, you move to state 0 1, that is this transition, and the output is 0 0. And when you get a 1, the output is 1 1, next state is 0 0. So, when you are at 1 0 and you get a 1, the next state is 0 0 and the output is 1 0. And let's, so this we have all enumerated. So, only thing left is when you are in state 1 1. When you are in state 1 1, you get a 0, you move to state 1 0 and output is 0 1. So, state 1 1, you get a 0, you move to state 1 0 and the output is 0 1. And finally, when you are in state 1 1 and you get a 1, you remain in state 1 1 and the output is 1 0. So, that is this line. So, note that here this trellis section, I have drawn the same information as I had in my state diagram. Only thing now you have this. So, in trellis diagram what you do? You just combine all these trellis sections. So, let us say this is trellis section at time L, this is trellis section at time L plus 1, this L plus 2. So, that is how we add this time dimension to the trellis diagram. So, for example, initially let us say your convolutional encoder is all 0 state. So, in that case what is going to happen? You are in all 0 state, let us say all 0 state is 0 0. So, if you get a 0, you move to 0 0, and if you get a 1, you move to 0 1. And next time instance, if you get a, if you are in 0 0 state, you move here, and if you get a 1, you move here. Similarly, if you are in 0 1 and you get a 0, you move to this state, and if you get a 1, you move to this state. And let us say I want to terminate this encoder. I want to terminate meaning I want to bring this encoder back into all 0 state. So, then in this step what I am going to do is I am going to bring it back to state 0 0 and 1 0. So, from state 1 1, if I get a 0, I move to this state, and from state 0 1, if I get a 1, I move to this state. Similarly, from 1 0, I can move to 0 0 state if I get a 1, and from 0 0 I can move to 0 0 state if I get a 0, and finally from 0 0 state, if I get a 0, I move to all 0 state, and from 1 0, I can move to 0 state if I get a 1. So, you can see this how the states are evolving with time, that I can see in the trellis diagram. With this, I will end my discussion on state diagram and trellis diagram. Thank you.